I'll be talking about the most important device that dominates in the industry today as a field effect transistor. Most of the transistors that is used in modern electronics is field effect transistor, or specifically MOS field effect transistor, or in short MOSFET. Before I start the technical details, I would like you to see a video. Let me try to share. Windows.
Sir, your video sound is not audible.
Sir, audio is not coming from the video.
So you have to screen share via window mode, sir, not screen share.
Yes, sir. There is an option window share, so the audio of the video will come.
Allows the audio, sir.
This is too hectic.
Sir, please unshare
first.
Unshare first. There, then click on share button. There is an option window share. Then share. Sir.
And select the YouTube or Chrome window tabs.
And allow computer audio.
Anything left?
भाई इसके ग्रुप का नाम भाई क्या कर दिया भाई अरे भाई कौन है
कौन है भाई ये कौन है
भाई ये गेस्ट
क्या गाना बजा रहे भाई
वो अबे पढ़ाई नहीं किया भाई
अब यार कुछ ज्यादा नहीं हो गया अरे हुआ क्या
ज्यादा हो गया भाई
कुछ ज्यादा चलो भाई
वाला
अरे गेस्ट खेलते थे लोग गेस्ट आया था
तो गेस्ट
भाई कौन था भाई
समझा तो यार मजाक करता
क्या है सही है भाई
सर नहीं लगी सर
वीडियो क्या होता है
अरे रिकॉर्ड किया है कोई
अधिकारी होता है क्या पोस्ट बड़ी होती है उसकी अरे काला खवान में आया था क्या नाम था उसका
इधर का नहीं था
Guest आया
Everyone keep saying something.
Sir, only accept the students who are in our organization in Durgapur.
Yes, sir. Kindly do not accept guests. That was someone using their personal mail ID outside NIT.
See, if you are trying to play very smart, you will be losing yourself. It's not your personal playground. If you do not want to attend class, please leave the meeting. And there are many ways to track your identity. It's just that we are not interested. It's very easy to track your identity. I do not know if you are not interested to attend class, why you have joined NIT? I cancel today's class. I'll have better setting in the next class to control your behavior more carefully.
Excuse me, sir.
Yes.
Sir, there's a misunderstanding. Sir, it was not anyone from us. Sir, it was someone
Yes, sir. I
from
don't
outside.
think it was this NIT student at all. It
Yes,
was
sir. He
someone
was
from outside.
from outside,
Yes, sir.
sir. Outside the
Join the
institute,
class
sir.
without
He just came to this.
Outside
without following
our
institute mail
class.
ID, sir.
He was guest,
Tail
sir.
one student.
Sir,
Yes, sir.
someone,
Sir, they do this in
Joined
every
as a
class.
guest.
They are not NIT students.
someone has got the link and joined.
How could someone
Yes, sir.
get the
With his
link?
Sir,
with
links
his
will be shared
personal
in
ID.
class, sir. Someone would have sent to his or her friend, sir. That's why, sir. None of us from NIT, sir.
Yes, sir.
Yes, sir. It was a guest account
Sir,
from his
you can
personal mail ID.
disable mic.
Institute
Sir,
student can
there's a
join.
setting, sir. You can allow only valid email ID students inside who is having
Yes, sir.
all.
People using
Don't allow
NIT email
guests.
ID only.
Otherwise,
Sir,
some
yes,
other
sir.
guests can join, sir.
Otherwise, anyone
Sir,
can
in
join.
the
Okay.
lobby settings, sir. Bypass lobby setting, you can do that.
Uh,
Allow
the-
only
Yes, sir.
Oxford
Sir,
organization.
I think the
Anyone
same
from the
guy,
world can join through her personal mail ID here, sir.
the same boy does this every time, I guess.
Sir, stop the recording first. Sir, are you there?
Yeah.
सर मैं बोलना चाहता हूँ कि आप ज्वाइन करने से पहले मुझे 2 बार निकाल दिया गया था इस क्लास से। आप मतलब प्लीज पता लगाइए कौन ये कर रहा है।
उसकी सेटिंग हो चुकी है और वो पता भी नहीं लग सकता भाई।
अरे तुम्हारा या तुम्हारा दोस्त का कुछ काम धाम नहीं है कि मेरा भी कोई काम नहीं है क्या? हम लोग लोगों का कोई काम नहीं है क्या?
सर आप रिकॉर्डिंग बंद कर लीजिए, फिर उसमें देख लीजिएगा किसने गाना चलाया, तो उसमें उसका नाम दिखा रहा होगा मोस्ट प्रोबेबली।
That was probably
yes,
not
yes,
recorded,
नाम
so अब नहीं दिखाएगा।
तो इसलिए बोला रिकॉर्ड।
सर मुझे 2 बार ग्रुप से निकाल दिया।
So that's why I was saying stop the recording, then you can check it from yourself only.
See, if I have to do all these things, then when should I take the class?
So, sir, first we will find out that one. Sir, if we will find email ID also, that is sufficient.
See, one can create thousands of fake mail IDs in no time.
Yes, sir.
you
From
should
next
allow
time,
one
kindly
who
accept
having
only
.in
NIT
at
mail IDs.
.in email IDs.
Yes, sir. The NIT DGP official email IDs that we received, kindly accept only those people.
Yes, sir. Don't
Sir,
allow
there
guest
is
or other email
option
IDs
in
to
my
join.
test lobby.
They will
There
have
is
an account
option
as
in my
guest.
test lobby. Arey wait, let's do okay. Can you share the screen again?
Sir, you
Sir,
can
please
ask
share
other
the
professors
screen
about
so
this.
that we can help you to do that.
So what should we do further, sir?
Just wait for 5 minutes. Could someone confirm whether the slides are visible?
Yes, sir. Slides are visible.
Yes, sir.
Please
Yes,
confirm.
sir. Slide is
Slide is
visible.
visible.
Okay, let's begin. I'll share the link of the video.
Okay, sir.
Please go through. It's a nice video about the field effect transistor. It explains with animation how the field effect transistors work. Okay. So today, whatever time is left, I'll discuss about the MOSFET, which is most dominant device in today's electronics industry. In fact, it is uh, the workhorse of which the IT industry is living on. So, if you see the field effect transistor, in short FET, there are primarily two types of FET. One is called junction FET, another one is called MOSFET. Junction FET relies on junctions, although it is not similar to that of the bipolar junction transistor. The use of junction FET it came up in the market earlier than MOSFET, but once MOSFET has been developed and it's largely used in all electronic gadgets that we use today, we'll spend a significant amount of time describing the MOSFET. Remember, the MOSFET is used almost everywhere. More than 90 to 95% of the transistors that we use in modern gadgets use MOSFET. So it's most important device in today's IC industry, specifically integrated circuit industry. So what we'll do in this MOSFET study, we'll go through the device structure and operation, the IV characteristics. IV means the current voltage characteristics. MOSFET circuit behavior under DC condition. MOSFET can also be used in the designing of amplifiers. Okay. Remember the MOSFET that we use in cell phone, in laptop, in desktop, in servers, in GPUs. Mostly they are used as switch. Switch means it will have something like on-off characteristics. It can be turned on, it can be turned off by using a control terminal. And in fact, that's what all the transistors are supposed to do. It should fundamentally show a very good switching property. Switching property means it should have on-off characteristics. It could be, it's kind of a mechanical switch, but no moving parts are there. Then we may not be talking about small signal operation models. We'll discuss about the fundamental amplifier configurations. Biasing is important in any electronic circuits. Depending upon the biasing, its characteristics can be altered. Okay. I should not say characteristics. It's you can use it as a switch or as an amplifier depending upon how you are biasing the transistor. The body effect and other topics are a little advanced. Okay. So this is what I was talking about. Primarily, the field effect transistor is of two types. One is JFET. It was invented earlier than MOSFET. And the other one is MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. So field effect transistor is common to both. Here in MOSFET, we have metal oxide and semiconductor. Is see the acronym, metal oxide semiconductor field effect transistor, and here we have junction field effect transistor. Then depending upon the type of carriers that is used for transportation of current, there could be a P-channel device and there could be N-channel device. So N-channel device uses a channel. Channel is the region through which the current is transported. So that is called channel. So if an N-type material is used in channel, then that is called N-channel, and if the P-type material is used, then it is called P-channel. In MOSFET, there are again two types. One is called enhancement type, another is called depletion type. And again, in enhancement mode or enhancement type, we have two subcategories. One is P channel, another is N channel. In the depletion mode, we have again similar classification. We could have P channel and N channel. And the most dominant player is basically the enhancement mode devices. In fact, we normally, whenever we talk about MOSFET, we simply mean that it is enhancement mode devices. The difference between the enhancement and depletion is that you enhance the conductivity of the channel in enhancement mode devices, and you reduce the conductivity of the channel by in depletion mode devices. So if you consider we have a control terminal, then in enhancement mode, the control terminal will be able to enhance the conductivity of the MOSFET, the current of the MOSFET. In depletion mode, primarily the control terminal will be removing the carriers from the channel, and thereby the current will be reduced. It's just the other way. So most dominant player is that is used in all electronic gadgets, be it your cell phone or laptop, desktop, PDA, everywhere. The type of transistor that we use is basically a MOSFET, and by MOSFET, what we mean is predominantly enhancement mode MOSFET. Okay. The field effect transistor differs from BJT significantly. First, it is a unipolar device. By unipolar, what we mean is that the current carriers are either holes or electrons. It's not like BJT, where both type of carriers are used in current transport. So in BJT, whether it's NPN or PNP, both electrons and holes take part in formation of current, flow of current. whereas in field effect transistor, the current carriers are either electrons or holes. The second point is very important. It is simpler to fabricate and occupies less space in integrated form. By integrated form, what I mean is basically IC, integrated circuits. The MOSFET is the key element to realize any circuit in integrated form. In integrated form means all the transistors, resistors, or capacitors are connected in miniaturized form in one single substrate. It is simpler in construction, therefore simpler to fabricate. Fabricate means simpler to realize in silicon. And as it is simpler, it occupies less space. And one of the key one of the important feature of MOSFET is that it is scalable. By scalable, what we mean is the transistor dimensions can be reduced proportionately. For example, if a transistor having dimension of something like 100 nanometer by 100 nanometer, it can be scaled to a lower dimension, maybe 50 nanometer by 50 nanometer, easily keeping the characteristics of the device intact. So when you reduce the size of the transistor, you can pack more transistors in the given area, and thereby you can realize more functions. So packing density may be extremely high. By high, it's quite common. For example, the Snapdragon processor, most of the mobile phone companies using Snapdragon SoC that contains more than 2 billion transistors. I repeat, that contains more than 2 billion transistors. And people are trying to pack more transistor into the processor to add more functionality so that it can perform more complex tasks, multiple tasks at lower speed, is at high speed. So MOSFET at this point makes MOSFET the dominant player in the industry. Simpler to fabricate, occupies less space, and thereby the packing density is increasing day by day. Third point is it has high input resistance. High input resistance implies it doesn't draw any current. Resistance high means the current will be V by R. So it will not draw any current from the source. It can be used as a symmetrical bilateral switch. By symmetrical, what we mean is that the terminals can be interchanged. If I compare it with BJT, for example, the terminal like emitter and collector cannot be interchanged in a BJT. You can do that, but that will degrade the performance of the BJT drastically. It cannot be considered as a BJT. In MOSFET or FET, typically, the equivalent terminals are source and drain. Source can be considered as emitter and drain can be considered as collector. So the source drain can be interchanged. You do not have to worry about whether you are connecting it to the collector or emitter. Either one will act as collector and the other one will act as emitter. So it gives you higher design flexibility, and it can be therefore used as a bilateral switch. Bilateral means it can conduct current in both the directions.
Sir, one question.
Yes.
Sir, if it can conduct in both direction, then how can it act as a switch?
No, the point is something like this. Okay, you consider a switch something like this. All right, this is the switch. All right. So switch is here. When you press the switch, it will be closed. When you release it, it will be open. By bidirectional or bilateral, what we mean is that the current direction can be this way or this way. There is no issue. For example, in case of a diode, the current conduction can only be from P to N, not from N to P. Does it make sense?
Yes, sir.
Yes, sir. If you consider a simple diode, the diode is also kind of a switch. Okay. So, but the current flow is in one direction. By bilateral, what we mean is that the current transportation can be from left to right, from right to left.
Okay,
and it is basically due to the symmetrical nature of the switch. It functions as a memory device. The pen drive, the flash drive, SSD, DRAM, RAM, all the things that you use, they use MOSFET. In fact, if you open any electronic device, you will see that 95% of it contains the MOSFET. So, and you also know, I think, that the cost of memory devices are coming down year after year. It is because of the packaging density is increasing year after year. If you could pack 2 billion transistors today, typically after 2 years down the line, you will be able to pack 4 billion transistors in the same processor. So memory is one of the key requirements in digital circuit. And by the way, the MOS dominates because it is a better switch than BJT. So in terms of switching behavior, which is fundamental to any digital design, digital logic, digital circuit, they all use switches. And MOS is a better switch. It is less noisy than bipolar transistor. Primarily, the reason is because bipolar transistor uses both electrons and holes in current transport. So it's like both carriers are there. So when both carriers are there, the interaction between them is kind of random. So noise will be more. If the current carriers are only holes or electrons, the noise will be less. It exhibits no offset voltage at zero current. Here, current is missing. It exhibits no offset voltage at zero current, hence make it an excellent chopper. Forget about all these terms. Basically, what it means that when the switch is on, there will not be any voltage drop across the switch. The voltage drop across the switch can be zero. In fact, ideally, a switch should have no drop across it when it's turned on. And when, in fact, that means the on resistance ideally should be zero or very, very small. And when the switch is off, the resistance should be as high as possible. Something of the order of maybe 10 to the power 10 ohm, 10 to the power 12 ohm or so. So that there will not be any current. So it's already 10:53. I want to stop here. Before that, I want to take questions. Hello?
Yes, sir. Sir, what is mean by less noisy, sir? In the point 6?
Noisy means whenever you consider the current through a register, for example, okay, the current through a register is I equal to V by R. Okay, it should be flat.
So what is the meaning of symmetric bilateral switch?
Symmetrical means you can interchange these two terminals. For example, in a BJT, you have three terminals. Base is the controlling terminal, and collector and emitter are the control terminal. That means the terminals to be controlled by base. Symmetrical, by symmetrical, what we mean is that the collector, it is kind of collector and emitter can be interchanged. You can use anyone as collector and the other one as emitter, or vice versa. Does it make sense? If I consider the symmetrical behavior, let me show. See, here is a structure of a MOSFET. Okay, this is called the source terminal, this is called the drain terminal, and this is called the gate terminal.
Sir,
If I
so
try
we
to
have
draw, hello?
11 a.m.
Yes.
So we have class from 11.
Yes,
So I want to stop here. If you have no further questions, then I'll close this session.
Sir, can you share this PDF, sir,
Oh, sure.
of slides?
Sure.
Yes, so the presentation.
Yeah, this PDF.
Sir, kindly share.
Okay. I'll be sharing this presentation.
Okay, sir.
Thank you.
So stop the
Thank you,
recording.
sir.
Thank you, 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 sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Thank you, sir.
Sir, have you taken the attendance?
Thank you, sir.
Sir, have you downloaded the attendance sheet?
I'll be downloading.
Okay, sir.
So can we leave the class?
Please leave.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.